In this video, we'll begin a new section of exercises from 19 through 36, where we want to find points of inflection and discuss the concavity of the graph of the function. You recall that a point of inflection is simply a point on a graph where concavity changes from up to down or from down to up. And we find that by finding where the second derivative changes sign. That's all we're really looking for. So let's get started with number 19. At 19 we have f of x is 1/2 of x to the fourth plus 2x to the third power. Our first derivative is 4/2, which is 2, reduce the exponent by 1, 2x to the third, plus 3 times 2, 6x to the second power. Our second derivative will be 6x squared plus 12x, and we can factor that as 6x times x plus 2. That's our factored form of the second derivative, which we'll use in our analysis. Then we want to set that equal to 0, and when we do, we find that x is equal to 0 or x is equal to -2. These are our potential points of inflection. So we're going to make our sign chart, place our potential points of inflection, -2 and 0. Note that we're working with the second derivative. Select some test values in each interval, and we start to plug into the factored form. We plug in -3, we'll get negative times negative, which is positive. Plugging in -1, we'll get negative times positive, which is negative. Plugging in 1, positive times positive is positive. So we can see that we have concave up, concave down, concave up, and at -2 and 0, concavity changes. So x equals 0, x equals -2, x equals 0 are points of inflection. We'll discuss the concavity. We have concave up from -infinity to -2, and from 0 to +infinity. Concave down from -2 to 0. Now I'll bring up the graphing calculator and we'll take a snapshot of what this graph looks like and compare to our results. Alright, so we have 1/2 x to the fourth. I'll put that in as 0.5 x to the fourth power plus 2 x to the third power. And we will just go ahead and zoom standard and see what we get there. Alright, so you can almost see if I change the graph a little bit, we'll make it go from -5 to +5 on the x values. -5 to +5 for the x's, and have it go from, looks like we didn't see the whole graph there, say from -15 up to 10, maybe by 5s on the y, and we get a clear shot of what we needed there. So I'll take a snapshot of this, and you can see that at x equals 2, -2, notice that point right there, the graph changes from being concave up to being concave down, and then at 0 it changed from being concave down to being concave up. So there are our 2 points of inflections, and we can clearly see the concavity of the graph matching our analysis. We'll go on to number 21 now. For number 21, we have f of x is equal to x cubed minus 6x squared plus 12x. The first derivative is 3x squared minus 12x plus 12. Second derivative is 6x minus 12. If we want to factor, we'll get 6 times x minus 2. That becomes the factored form of our second derivative. And when we set that equal to 0, 6x we set 6 times x minus 2 equal to 0. We have x equals 2 as the only potential point of inflection there. So we'll make our number line. We're working with the second derivative. We have a potential point of inflection at x equals 2. We select 0 and 3 as our test points, and we're going to plug them into the factored form. When we do, plugging in 0, we'll get a negative. Plugging in 3, we get positive. And so x equals 2 is a point of inflection. And as far as the graph is concerned, we have concave down, concave up. Our graph is concave up from 2 to infinity, concave down from negative infinity to 2. Alright, we'll bring up the graphing calculator. And here we have x to the third power minus 6x to the second power plus 12x. We'll zoom standard and see what we get. Alright, well, we can see one point of inflection in there, but I'll adjust the graph a little bit. We'll go from negative 5, window, from negative 5 to positive 5 by 1, and from negative 5 to 10 by 1. Let's see if that helps at all. So I'll take a picture of this, put it on our workspace. So we can see at x equals 2, clearly the graph went from being concave down to being concave up, and so x equals 2 is our point of inflection. We are concave up from 2 to infinity, concave down from negative infinity up to 2. And that'll do it for this video and for these two problems. Again, we were working on problem number 21 here.